Welcome back to Chemistry 2, Unit 4, Chemical Kinetics. This is Lesson 1, Video 3. So here we have another reaction. Hydrogen peroxide, H2O2. So we keep it in a brown bottle to prevent this reaction from happening because light will degrade hydrogen peroxide and give us water and oxygen. So this happens over time. Peroxide is not a very stable substance and it breaks down readily. So if you've had a bottle of peroxide in your medicine cabinet in your bathroom for more than a couple years, it is probably mostly just a bottle of water. There might be a little bit of peroxide left in there as long as it's kept cool and out of the light. So if we look at this, we have coefficients here. These are going to give us some problems. So our rate of reaction for this. Well, we know that we could define rate of reaction for this whole reaction based on the changing concentrations of the substances in here. So we know that it is the negative of our reactants. So it's a negative change in concentration of H2O2 over change in time. Or if we wanted to talk about the concentration of water, that's a little bit hard because water dissolved in water, but we'll go ahead and put it. That would be the positive change in concentration of water over time, or the positive change in concentration of oxygen over time. But our problem is coefficients are present. So the above rates need to be altered to reflect the effect of coefficients. So if we look at this and we look at the reaction, peroxide with that 2 means it takes 2 moles of every peroxide will give us 2 moles of H2O2, but only 1 mole of O2. So every 2 moles of peroxide, we only get 1 mole of oxygen. So in order to make these two equal, we know that this and this are in a 2-to-1 or 1-to-2 ratio, depending on how we look at it. So half of this rate would equal the rate of formation of this. So the way that we talk about that is something called the general rate of reaction formula. And I'm just going to give you a generic formula using letters, so without substances. So a little a and a capital A. So little a would be our coefficient in front of A plus B little b yields little c big C plus little d d. So we have 2 reactants and 2 products. If we want to calculate or use this, we have to have a general rate of reaction formula. So the rate of reaction, let's put an equal sign there, is equal to, well, if we have a coefficient, whatever that is, we know that it's going to be negative because this is decreasing and we want our rate to be positive. So negative 1 over little a times the change in concentration of A over time. That is going to equal the negative 1 over little b, so it takes into account the coefficient, times the change in concentration of B over the change of time. We can also define it equal to C, and this time it's positive, so 1 over little c times the change in concentration of C over the change in time, and that is equal to 1 over little d times the change in concentration. So what this is telling us is we can determine the rate of reaction if we know data about just one of these substances. These are all equal to one another with this form. So if we know information about B, we can find out what A is doing, what C is doing, what D is doing, because they're all equal to one another. So the average rate of reaction assumes that rate is constant over time. Constant over time means that it is a straight line graph with slope equal to the rate of reaction. So if we go back up to this general rate of reaction formula, these two up here, because they have the negative values and these are the reactants, these are called rates of disappearance because these substances are disappearing over time. These two over here are products. They have a positive value in front of it, so we don't write it, but these would be positive. These are the rates of formation because these substances are being formed during the course of the reaction. So these are the terms that we're going to use in example problems. So again, if we know data from one of the reactants or one of the products, we can generate a general rate of reaction formula to figure out what is the rate of reaction and what are the rates of formation and rates of disappearance of substances within that reaction.